Good morning, everyone. Welcome to Engineering Tomorrow's Remediated Site Special Lab event. We are so pumped and excited today and hope you're ready to work on these oil spills. And Joanna will tell you all about it. We ask that you remain on mute throughout this wonderful introduction we're about to have, and then we will have lots of opportunity to talk to each other and engage throughout the day. I am so excited to hand this over to your fantastic engineer presenter today, Mrs. Joanna Cottle.
Good morning, everybody. I am also really excited to be here today and talk to you about this really important topic. I think it's one that maybe we don't think about all that much in our everyday lives, but it actually affects every community in the country, I could probably confidently say. And um, and so I want to tell you more about it, and I want you to have fun thinking like engineers on how would you solve the kinds of problems that we're going to talk about today. So what are we going to do? We're going to be modeling an oil spill. We're essentially going to be remediating a body of water. And you're going to learn a number of different remediation methods today. And then you're going to clean up your oil spill. You're going to come up with your own design, your own scenario of where this oil spill is occurring. And then you're going to learn ways that engineers use to clean or remediate sites. We've got a really fun day ahead of us. I'm going to talk to you for a little bit and give you a good introduction so that you will be confidently on your way after when you get your kits and you start working on the challenge. Then you're going to have about an hour to work on the challenge. You're going to be joined by some engineers and college engineering student mentors, and they'll be there to answer any questions and help you get underway. And then we'll come back, we'll all join back together, and I will be joined by two engineering college students, Romina Camrina and Morgan Douglas, and they have a number of specialties in this area, and they will be able to answer all the questions that you have. And then lastly, we are joined by a very inspiring keynote speaker today. Miss Arredondo is going to share her story, her journey to engineering, and her work as a chemical engineer with the energy company Chevron. She works at a refinery in Northern California in the Bay Area, and she's going to talk to you about what it's like doing her job, and also a lot about how she and her colleagues really work to protect the environment where their work is being done. So I think you'll learn a lot from her as well, and I'm really excited to talk with her this after we finish up the challenge. As with all of our challenges, they are always developed by professional engineers and a team of college students. And this one was developed by my colleague, Carla McQuarrie. She's an environmental engineer and she works in remediation and lives in Nova Scotia. And she was joined by Ali Sack, who's a biomedical engineer. So there's so much good content in your student workbook or your abbreviated worksheet that you can use to learn more about this topic. A little bit about me. I have a background in physics and engineering. I did something called a dual degree program when I was in college. And so I've been fortunate to have two big careers in my life. I spent the first half of my career working as a mechanical engineer for a big global construction company. I worked in power generation, I worked in water treatment, I worked on the maintenance of some nuclear power plants and had a very rewarding career as a mechanical engineer. And then I was fortunate to be able to also work as my other love, which is being a teacher of high school students, just like you in the classroom. I also got to coordinate the STEM program at my high school. I live in the Maryland area near Washington, D.C. So I taught at an all-girls school. So go women engineers. And I've been able to work for the incredible Engineering Tomorrow company for about the last 5 or 6 years. And I have to say, I'm so amazed at the growth of the organization and the reach that we've had. And it's really exciting to be joined by thousands of you today across the country. So this is a really fun job I get to do, and I'm really hoping that you have a fun time with us today. So let's jump right into what we're going to be talking about. Um, I think you've probably heard about some sites that have become contaminated. You've probably heard about some big oil spills that have happened. Sadly, you might have heard about drinking water becoming unsafe because of chemicals that were leaking into groundwater or, potentially leaching out of piping. We've all probably heard about the lead pipe uh, contamination of water in Flint, Michigan. Um, you might also have heard about the buildup of contamination in ecosystems. I know I'm personally hearing a lot about microplastics and also about the chemical compounds that are used on like nonstick coating and um, water repellent on raincoats and things like that. These are called polyfluoride chemicals, PFAS, and we're learning a lot about those building up in the environment and being harmful to wildlife and humans. And so there's some new regulations by the EPA actually to monitor for uh, the outload of those chemicals. And then finally, something that I'm more familiar with from my mechanical engineering background and certainly in the power generation business is runoff from the waste products of industry. In particular, we have a lot of old coal plants. They've been running for decades and decades, and there's been a few cases where the ash from the burning of the coal that's stored on site it's kept in these ponds, and sometimes these ponds can leak into water bodies that are nearby. And so there's been more work to try to prevent and do a better job of keeping any runoff from industrial sites from happening. All of these are contaminated sites, and they all require engineering expertise to make sure that they are kept safe. Um, and so now I'll kind of want to talk to you about what can environmental remediation do. And so I'm going to play you a quick video of a story about a site that was remediated and then returned to public use. So watch this, and as you watch it, I'd really like you to maybe focus in on uh, who was affected by the waste that was happening in this community, who were the players that got involved to clean it up, and how did engineers come up with a solution? Because that's going to help you think more directly in your teams today about how you might remediate a site. Colorado is home to a nationally recognized recreational trail. Sorry about that. Leadville, Colorado is home to a nationally recognized recreational trail, a gold medal trout fishing stream, and a $1.1 million sports complex. However, these amenities were not always part of Leadville's landscape. The town was part of an 18 square mile area of hazardous waste contamination. A legacy of 140 years of mining activities contaminated soil, surface water, and sediments with heavy metals. High lead levels posed risks in residential and commercial areas. Children, in particular, were at risk for elevated blood lead levels. The environment suffered as well, with acid mine drainage taking a heavy toll on the Arkansas River, destroying native vegetation and wildlife habitat, and threatening downstream water supplies for recreation, livestock, irrigation, and public drinking. The threat to human health and the environment led EPA to designate the area as the California Gulch Superfund site in 1983. Cleanup activities have made large portions of the site safe for reuse, allowing Leadville to reimagine its future.
The community came together to transform a portion of the site into a recreational sports complex, amenities the community had never had before. Across the country, EPA's Superfund cleanup activities have helped pave the way for communities to reclaim and safely reuse Superfund sites.
So here you saw a mining operation that was turned back into usable land. And you also heard about this term Superfund. And the Superfund process is a process that kicks in and provides at the state or the federal level to provide funds to help clean up a site when there's not sufficient funds or not enough responsibility being taken by the company caused the waste. So it's a multi-step process, as you can see here. It's sort of a pathway that we're showing you where the site is evaluated and an evaluation is performed to determine the amount of remediation that's needed. And then it is kind of a plan for remediation occurs. There's a design that's done, and then that design is put into effect, and the site is cleaned up. And then it is reviewed to see how the site indeed clean? Is there any more leakage occurring? So that's the operation and maintenance phase. And then it gets removed from this list. This NPL list is NPL stands for National Priorities List. And it's a way for state and federal governments to determine how to best use funds to support the cleanup of sites. So when might this happen? Well, let's say in the Leadville mining operation, perhaps the company didn't have sufficient funds to clean up the site after it left. And so a state or a federal program would help support the cleanup to make sure that it couldn't be harmful to the community. Sometimes these funds are used for sites that were owned by the federal government, and I'm going to talk to you about one of those in a minute. Um, Certainly, as we learn more and more each time about sites, um, we try to, I think entities try to make sure they plan for the required cleanup and maintaining a stable site later on. So I know in newer mining operations these days, the companies are required to put aside funds in a savings bank to make sure that that money is available to keep the site safe and secure for decades to come. So these processes, we learn more and more about them, and we try to get better and better about making sure that current industrial sites can't contaminate for the future. I wanted to share a bit about one site. One of the biggest Superfund sites in the country is, and these are also in Europe as well, in the UK and Europe, are former nuclear processing sites. And one of them that my company has been involved with for many years is the Hanford site in Washington State. This was if you watched Oppenheimer, you've heard of the Manhattan Project. This site was a place where nuclear bombs were developed for the Manhattan Project and then ongoing as part of the Cold War. But after the Cold War ended and the site was closed, it was discovered that some of the radioactive waste from the bomb processing, the plutonium processing, that had been stored in tanks was leaking. And so a team of engineers from multiple companies needed to come in and help the Department of Energy come up with a way to prevent this from leaking into ecosystems in the surrounding area. And you can imagine radioactive waste is amongst the most hazardous kind of waste that needs to be cleaned up. It takes decades and decades for radioactive waste to become non-harmful. So the types of engineering and the tools that needed to be developed, these processes hadn't even been developed yet. It really took some innovation and a lot of planning to make this happen. And so, again, think like engineers. Think about what would be involved in trying to clean up a site with something as detrimental to the environment as radioactive waste.
I'm not hearing you. What's going on, okay?
50 years, just a few miles from the last free-flowing stretch of the Columbia River. The Hanford site produced weapons-grade plutonium that helped end World War II and later the Cold War. This unprecedented effort generated massive amounts of chemical and radioactive waste. 56 million gallons of that waste is currently stored in 177 underground tanks, some of which are presumed to have leaked, threatening the groundwater and the nearby Columbia River. Treating Hanford's waste presents a unique challenge because of its complexity. The Hanford tank waste consists of liquids and salt cake, a material with a consistency like wet beach sand, and deposits as hard as rocks. Other waste is the consistency of peanut butter, and each individual tank has its own diverse mix of chemical and radioactive waste. To solve this problem, the Department of Energy contracted Bechtel National to design and build a facility to treat and immobilize the waste. The Waste Treatment and Immobilization Plant, or VIT plant, will use a process called vitrification to immobilize the waste in solid glass for safe, long-term storage. Vitrification is a proven technology used in the United States and Europe, but never on the scale and complexity of waste found at Hanford. In the low-activity waste facility, waste will be mixed with glass-forming materials and heated to 2100 degrees Fahrenheit in two 300-ton melters, poured into stainless steel containers, cooled, and prepared for storage. The facility will produce 21 metric tons of immobilized glass per day. In glass form, the waste will be stable and impervious to the environment, allowing its radioactivity to safely decay over thousands of years.
So there you could hear, I want you to think about the types of temperatures that they need to reach in order to create molten glass is similar to what you would have inside a volcano. And so the technology that was developed was first of its kind. And then you need to think about how do we keep all the people that work at that site safe? How do we protect them from any radioactivity from this low radioactive waste? How do we make sure that the process is efficient and lasting, that it's sustainable? So many things went into this, and I'm proud to say that the VIT plant just had its first full-fledged test and has made several thousand tons of this molten glass rods that are going to be stored in these steel tanks. And they expect to go into full operation next year. So it's been a huge effort. It's cost billions of dollars. And so certainly, as we're going to hear later from our keynote speaker, the best way to prevent the need for remediation is to make sure that you're doing everything you can during these industrial processes to prevent any leaks or things like that. And that's also a big part of engineers and scientists do. Um, Not every, next one, there we go. So not every remediated site is a Superfund site. Um, Smaller sites can be uh, cleaned up and remediated with the help of funds from local alliances, communities that gather together. And I wanted to highlight um, Preston High School because they asked, do you have any specific examples of the remediation process happening in the Bronx? And as I mentioned, everywhere in the country, there are sites that are being remediated, and you can do a quick Google search to find out some near you. But I wanted to spotlight the Bronx River Alliance, which cleaned up and restored the area around a former concrete plant, and has now turned it into a waterfront promenade and seating areas and a canoeing and kayaking launch point. And there are many examples of industrial plants that are located along bodies of waters like rivers, and they are put in, they need to be cleaned up, and we need to make sure that they don't use, that they're not dumping any of their waste products into the river. And so there's lots of cases, certainly in my area, around the Chesapeake Bay, there's lots of cases of alliances of conservation groups that are trying to clean up the rivers and turn them back into usable recreation areas for the public. So let's get into what a contaminated site is and a little bit more about how we clean them up. So we've already talked about mining facilities and we've talked about industrial facilities. Landfills are another area that we also often have to be careful about, because as the waste in landfills breaks down, sometimes those contaminants can leak into the soil and the groundwater nearby. Often landfills have these liners at the bottom of them, but they can still fail from time to time. And then, of course, the big one that we're going to talk about today are oil spills and spills of chemicals into bodies of water. So what can we do to remediate these? How do we do that? What is environmental remediation? The definition is it is the removal of pollution or contaminants from water and soil to protect people's health and the environment. And you can see that the difference that can be made really changes the area for people, for the wildlife that lives there. We've seen a number of examples. So how's it done? Well, there's a number of different methods, and I want to just go through a few of them. These are not all of them, but these are some of the most common ones used. So excavation is exactly what it sounds like. That's where we're removing the contaminated material, probably putting it into steel drums or concrete tanks or things like that that can be taken away and stored up more safely. There's dredging. Dredging is like excavation, but underwater. And that's where you're trying to remove contaminated materials from beneath the surface of water. There's bioremediation, which you're going to, hopefully, if we have time, you're going to be able to work on today. You've got the tools in your kit. But that's where you add a microorganism to a process. And what that microorganism does is it helps to break down the waste product that you're trying to remove. And this can make it easier for you to extract the waste or to speed up the process of getting that waste out of the site area. Some more complex processes are things like pump and treat. Pump and treat is where you pump water down into the area, and then you extract it back out, and then you treat it with a water treatment plant, and then you put the clean water back in. Um, Another similar kind of idea is soil vapor extraction. In this case, you're putting air down into the area, and then you're sucking off the fumes, the exhaust from this process, because the air mixed with the chemicals that you're trying to remove, the waste product, and then you can remove it and remove it safely. And then in the middle there is a process called solidification. And this is where you inject something down into the waste product and you turn it from a watery leak substance that can leak into a solid. And actually at Hanford, this is another idea that's being considered, is to inject some grout, some special kind of grout or concrete into those steel drums that you saw, into those concrete tanks that you saw, to try to create a more solidified waste product of that highly radioactive waste so that it can be more stable and hopefully not go into the environment. It's not quite as proven and sure as the vitrification process, and so that's still being weighed. It costs less though. So I think as you're going to see, in your lab today, there's always a balance between the cost of doing the remediation and the work of the remediation, and you're going to be keeping track of your costs. So when we talk about contaminants and how we determine how we're going to remediate a site, these are the things that we have to consider. What is it that we're trying to remove? Is it something like lead? Is it pesticides? Is it oil? Then we have to consider, what is this waste product in? Is it in air, groundwater, soil? All of these things help us figure out an action plan for cleanup. And then finally, what is this site like? Is it near a city? Is it in a remote region where it's going to be hard to get equipment? Is it very near a very delicate ecosystem? All of these things play into the design for cleanup. And so specifically speaking about cleanup, you've all been thinking like engineers in your classes and using the engineering design process. And I showed you a slide before that showed you the process that's used for site remediation. And I want you to see the similarities between the two. They're actually very similar. So engineers try to learn about the problem. They try to design a solution about the problem. They build it, they test it, and they deploy it. Now, if we look at the cleanup process that's used in site remediation, you can see that there's a learning process where you're investigating. There's a design process where you're figuring out what you're going to do. Then there's cleanup, and then there's testing. What might be different in this process is the other stakeholders that are involved. There's also often legal agreements that manage the payment and who gets involved. There's also the need for public participation. And so you have many stakeholders. And what I think about that is that it actually makes these kinds of problems really challenging, but really, really interesting, and giving you the opportunity to work with all different kinds of stakeholders. So a very interesting job for an engineer. So let's get started on what you're going to be doing. You're going to be modeling an oil spill. Not all oil spills are catastrophic oil spills. They can be things like perhaps in a small harbor where boats go to refuel. Maybe maybe the tank that holds the boat fuel starts to leak and causes a small leak. But there's laws that protect against oil spills, and also the monitoring and oversight of operations that use this to try to protect against oil spills. But generally they occur when there's some sort of equipment leak, or maybe there's some human error, and sometimes, in a big natural disaster like Deepwater Horizon or something like that. Something that I found when I did this lab, and I think this picture says it all, is when I was doing this lab, a thing that stuck with me literally was that how pervasive the oil is, how it sticks over everything and creates this film, and how it's so difficult to remove. And I want you to keep that in your mind today and think about how that must be so difficult to remove from the environment. And so you can see, we've all seen very sad pictures of wildlife with oil on their wings, and birds with oil on their wings, and shorelines that have oil washing up on them. It really is a very difficult thing to remediate. But there are tools, and we learn better ways to remediate sites all the time. There's always new technology. But some of the tools that you're going to use today, you could create a boom, and a boom is something that tries to prevent the oil from spreading further across the surface. You're going to have in your kit absorbents. You're going to have cotton balls and things like that. These are things that soak up the oil. You're going to have you're going to have materials in your kit that you could use to create a skimmer. And a skimmer allows you to move the oil around on the surface to make it easier for you to collect it. And then finally, you're going to have dispersants. In your kit, you'll have a little thing of dish soap. A dispersant is something that when you put it in the oil, it breaks up the oil so it can make it easier for you to collect or easier for it to be broken down in the environment. I caution you, you're only going to need a tiny bit of dish detergent to see a big effect.
Oil and spray.
Just a few more slides, and then I promise I'll turn you loose. One thing that you're going to harness today is the chemistry behind oil spills, and that is engineers use the fact that the density of oil is less than water and that it floats on the top of the surface to come up with their remediation plans. It's also good to remember that water is a polar molecule, meaning that it has one side that's more negatively charged and one side that's more positively charged. And because of that, it can repel chemicals that are not polar. So uh, a hydrocarbon is a non-polar molecule, a hydrocarbon like oil. And hydrocarbons are also hydrophobic, which means they are water-fearing. So luckily, oil and water don't mix, and we can use that to our advantage. Another thing that we mentioned is bioremediation, and I won't play this video. It's in your workbooks and it's available to you. But today what you have, remember that bioremediation is where you add a microorganism into the solution and it breaks down the waste that you're trying to treat. So you have a little packet of yeast in your kits, and you're going to add that to your remaining water that you have that has oil and sugar in it. This is after you clean up your oil spill. And that is going to help to break down the remaining sugars, which represent the dissolved chemicals from your oil spill. And you're going to see the results. That breakdown creates carbon dioxide. I'll show you some pictures in a minute. So I've been mentioning the materials in your kit, and here you can see a listing of them. You're going to have some straws. I created a very rudimentary boom with my straws. You've got popsicle sticks. I created a very rudimentary skimmer that I thought I could push along the surface of the water to try to move the oil when I made my oil spill. Be creative, come up with your own designs, and enjoy the fun of it. So we've talked about different remediation methods. Something that I really want you to do now is when you get into your teams, I want you to create your own scenario for the oil spill. Make it about something local to you or make it about a favorite place that you would love to visit, but be creative. Think about, maybe it's the river where you love to go kayaking near your home, or maybe it's an ocean location where you love to go on holiday. Maybe it's a water body, a wetland area near your high school. You come up with the scenario as a team, and then you figure out how you would clean up this particular location. And we would love to hear about that story that you create with your team. Once you come up with your location and where this oil spill is going to happen, come up with your design of how you're going to clean it up. Because if it's in a wetland, you might want to consider different tools than over out in the middle of the ocean, for example. And then I want you to build your tools to clean up your oil spill. And then I want you to create your oil spill. So let's see how you're going to do it. Here's some tools you can see. You can see the booms. I think you have a little pipette in your kits. So you can perhaps use a skimmer. You've got absorbent material for sure. So be thoughtful about how you'd like to do that and build those tools in advance of your oil spill. And then what you're going to do is you've got a little bottle of oil, and it may have some black flecks in it, which is oil-based food coloring. And then I want you to pour your sugar into that bottle and mix it up. And then if you would try to be, once you're ready with that, then I'd love for you to be slow with pour your oil in slowly. because I found when I did this, I wanted to try to replicate what it would be like if like a pipe burst into a bigger body of water. If you just dump all the oil in, I don't think it'll have quite the same effect of an oil spill type experience. So I'm just cautioning you about that. And then you're going to remediate the site. You're going to try to get as much oil as you can out of there. You can collect that on paper, a stack of paper towels or things like that. Keep track of what you collect because you're going to have to apply a cost to that. And then once you're finished, I want you to take your pan of water and what's left of the oil and sugar and pour that into your graduated cylinder and try to measure how much oil is left. You're going to see this little layer of oil at the surface, and you're going to try to measure that. And then you can take some of that mixture that you've got left and pour, maybe half of it into a water bottle if you have time, and then add your yeast into that water bottle and try some bioremediation. You may not have time to do that all in this hour, but I encourage you to do that because it takes some time for that yeast to break down the sugars. And it's quite exciting to see a balloon blow up as a result of the CO2 that gets generated from that bioremediation process. So I've told you to be creative. I've told you to take your time and be careful as you're pouring ingredients. And I really, really want you to relate your oil spill scenario to the real world. Try to think about where this might happen in your neck of the woods or in a favorite place that you love to visit. And with that, I'm going to turn you loose to go start on your project. I really hope that you enjoy the fun of this challenge, and I can't wait to hear about the stories you have to tell when you come back.
What an incredible introduction. Thank you so much, Mrs. Cottle. If you can tell, she's a former teacher. And we know that you guys are eager to get started. So we'll go ahead and open up the breakout room. At this time, there will be ET staff in the room, as well as two amazing college mentors. You'll meet them. So they're there to assist you if you have any questions or need any guidance. We'll meet back here at 11:30 EST so you guys can show and tell us what you've done. Have fun. See you soon.